Rational function. This is rational function part 2. Decomposing or resolving rational function into partial fraction. So rational functions are often the combination, that is difference between or sum of two simpler rational function. So example, so this is my two simpler rational function. Yes, in a basic school we were solving fraction, addition of fraction. Do you remember? 1 out of 2 plus 3 out of, let's say, 5. Then we will find the LCM of 2 and 5. Then we start solving. Yes, all those things that we are doing, this was waiting for us. So we already know how to use this one. So our LCM for here is S times S minus 2 because we take this and this, then we multiply. That's our LCM. So therefore, my LCM is S times S minus 2. And we say that S times S minus 2 divided by this S. So this S will cancel this S. So it's left with S minus 2. Then we use this S minus 2 times the 3. That's why we got 3 times S minus 2. We're doing this in the basic school. Then the next one, S times S minus 2 divided by S minus 2. So this S minus 2 will go this S minus 2. So it will cancel. So it left with what? S. Then this S times the 4. That's why we got 4S. So if multiply through by 3, this is what we get. Then our final answer is 7S minus 6 out of S times S minus 2. So this is the rational function and this is a rational function, right? Now, so with partial fraction, they may give us the answer. They may ask us to get this, the question. That's what partial fraction means. That's why I say resolve, okay, or decompose it, rational function into partial fraction. Okay, so someone have solved this and they are asking us to get the question for us. So I've seen that the LCM are the same. So that's why it's difficult to get the numerators. That's why we always represent the numerators by any alphabet. So as we are going, you see how it is. I hope you understand. So the answer is this. So I'm saying that with partial fraction, you will give us this. That is the answer. Then we will get the question. Mathematics is nice. Decomposing or resolving rational function into its original, that's the simpler part, give us the partial fraction of the rational function. That is breaking apart. So they will give us this, then we break them apart. Okay, so that's breaking them apart. So if they give us this, they break them apart. So this is what they will give us. Then we will decompose it or we will break them apart into this. So breaking them apart, they give us this, then we will get the question back for them. Right, that's all about partial fraction. It's not difficult. Very interesting topic. Rational function and its equivalent. So since we now know how we can deal with those things, we have to know the types. For factorable denominator with distinct factor, this one we have talked about it, and we know what factorable denominator with distinct factor. So if the denominators are different, so these are the factors. So its equivalent in order for us to solve, we have to know its equivalent so that we can solve it. We are saying if it's distinct factor, then it's a factorable. Then its equivalent is a out of one of these, s minus alpha plus b out of one of these. So if the denominator is factorable with distinct factor, this is how you go about it. That's its equivalent. Example, 7s plus 6, this. So in order for us to get the answer, you have to know its equivalent. So always the denominator that we know. So we take any alphabet P, then one of the numerator, the first numerator S, plus Q out of this S minus 2. So before we start solving it, so always with partial fraction, it's difficult to get a numerator. That's why we always represent the numerators with our alphabet. Okay, so this is how the equivalent goes. Another example, with this 9s plus 6. So I'm asking the denominator, is it factorable? Yes, it's factorable. So this one is a perfect square. So it's the same as s minus 5, s plus 5. So then a will take one of s minus 5 plus b out of s plus 5. So these are the denominator. So always expect this denominator into this s minus 5. So its equivalent is this. Factorable denominator with repeated factor, that one too, its equivalent is different. So with repeated factor, we are saying as plus b, the denominator, that's what we are looking, s minus a to the power n is this. Its equivalent will be a1, then s minus alpha. So this one will be the power 1. That's where it continues. Then we go the next step, a2 out of the denominator to the power 2. Then it goes until infinity, that's the n. So we don't know, it's to the power n. So if it is 3, then it will go a3 out of s minus alpha to the power 3. Example, so the denominator here, that's what we are looking. So its equivalent will be what? Let's see. So it will be a out of s plus 4, then b out of s plus 4 to the power 2, c out of s plus 4 to the power 3. So it will reach what? 3. So here is 3. That's how we go about it. So it's the power 1, 2, 3. So if it is 4, then it will continue. So as simple as that. So this one is repeated factor. So always, that's why you have to identify the denominator, the type, before you know its equivalent. For denominator with mixed factor, so they can mix the distinct and the repeated for us. So we have one distinct and repeated. So this is how it will go. So one distinct, then the repeated one will continue as we talk about it. So if the repeated is here, the repeated here will come first, then the one distinct will come. Right? Good. Example. We are talking about denominators. So with our denominators, its equivalent, we have one distinct here and repeated. So this have been repeated what? Twice, right? So with one distinct, it will be a s plus 3. That's one distinct. Then we come and continue. B plus the repeated s plus 9. We don't have to solve for the repeated, plus c s plus 9 square, because it ends with what? Square to the power 2. So if the power 3, we continue, plus d s plus 9 to the power 3. For non-factorable denominator, as we said in the type, some of the denominator you cannot factorize it. So it equivalent to is different. So with this, we have one distance and this is a quadratic where as squared plus bs plus c is not factorable. Cannot factorize that one. So this is how we go about it. Since this one we know is distance s minus alpha, okay, plus bs plus c, then our denominator here, this one we said you cannot factorize it. If you cannot factorize this is how we go about it. So since we have used a, we continue with bs plus c, then write the one that we cannot factorize it under it, as squared plus bs plus c. Example, this is what we are saying. The denominator s squared plus 2. Can we get the factors for this? No, you will not get the factors. Since you will not get the factors, therefore its equivalent will be, since there's s squared here, it will be as plus b out of s squared plus 2. So this is what I'm saying. As plus b out of s squared plus 2. With another example. So we have one distance and repeated. Please do not multiply through. So all this we are doing is proper fraction, right? So we have one distance. So this one will be a out of s. Then s squared plus 1. We cannot factorize that one. So it will be what? Yes. Good. bs plus c out of s squared plus 1. Good. As easy as that. So know the types and know its equivalent. Then you are good to go. As easy as that. Subscribe to Senior Fellows, my YouTube channel for more.